In this course, I'm going to cover some basics of relays and how to control them using the Johnny 5 framework. For my demos, I will be using this bad boy here, which is a 5-volt, 2-channel, single-pole, double-throw, active-low electromagnetic relay module made by SaneSmart. Now of course you don't have to use this particular relay to follow along with the demos, but there may be a few nuances that I cover with this particular relay that may or may not apply to yours, and I'll be sure to point those out as I touch on them throughout the remainder of the course. If you are interested in using the same relay, I've posted links in the course description, as well as here in the lesson itself to the one that I'm using. Now before I unpack the word vomit that I just spewed out regarding the type of relay I'm using, I want to get down to the basics and first talk just a bit about what exactly a relay is. There are certainly a number of different types of relays, but at their cores, relays are essentially just switches that open and close circuits. When working with electronics, especially microcontrollers that utilize low voltages, a relay can come in handy to switch higher voltage devices on and off, such as a lamp, or even trigger garage door openers. Now as I just mentioned, there are different types of relays, and the type I will be using throughout this course is an electromechanical relay, which is also called an armature relay. This type of relay is typically made up of fixed and movable contacts, a coil, and an armature. When the coil is energized, it produces an electromagnetic field that moves the armature and connects the movable contact with a fixed contact closing the circuit. When the coil is de-energized, the armature returns the movable contact to its default or resting position, which may connect with another fixed contact, creating a different closed circuit. I'll dig a little more into these different circuits in just a moment to hopefully clear up any confusion with them. Other types of relays include solid state, field effect transistor, and reed. I invite you to check out the link I included with this lesson to gain a better understanding of the different types available and how they operate. Now switches in general include at least 2 terminals in order to open and close circuits. Since a relay is a type of switch, it is no exception. There can, however, be more than 2 terminals in a switch to open and close more than one circuit, and depending on how those terminals are arranged, determines the type of the switch. Common terminal configurations in a switch are single pole single throw, single pole double throw, and double pole double throw. Of course there are other types or configurations, but these are probably the most common ones that you'll encounter. In the first slide, I mentioned that I'm using a single pole double throw relay, which means that the signal, or power source, comes through on an input terminal, aka the pole, and can move through 2 different output terminals, aka the throws. Closed circuits then occur when the armature that I mentioned in the last slide connects with the movable contact on the pole to either one of the fixed contacts on the throws. In this simple sketch, you can see 3 different terminals, with the left-hand terminal being an input terminal, known as the pole, and the 2 right-hand terminals being output terminals, known as the throws. Since there is a single pole and 2 throws, these are what classify my particular relay as a single pole double throw relay. Now this configuration can be found in a number of different switches, but in the case of the relay, the armature connects a movable contact tied to the pole with either one of the fixed contacts on the throws. In some cases, the pole can actually be connected to both throws at the same time, which is usually temporary as the connection is switched from one throw to the other. Now at this point you may be thinking, alright Thor, that makes sense and all, but when I look at my relay, I don't see the terminals marked with pole or throw. I actually see COM, NC, and NO. What do those mean? Here's another simple sketch that may resemble your relay a little more closely. This is still a single throw double pole diagram, just laid out a little differently. The pole terminal in this case is the COM terminal, which stands for common. It's called common because it connects with both of the NC and NO terminals, which are the 2 throws in this case. NC stands for normally closed and is the terminal or throw with which the common terminal is connected when the relay is in its default state. Put another way, when the relay is not triggered, the contact on the COM terminal is connected with a contact on the NC terminal, creating a closed circuit. NO, on the other hand, stands for normally open, since the contact on the COM terminal is not connected to the contact on the NO terminal when the relay is in its default state. Essentially, this circuit is normally open. When the relay is triggered, however, the armature forces the movable contact on the COM terminal to connect with the fixed contact on the NO terminal, creating a closed circuit here and opening up the circuit with the NC terminal. Now in order for these terminals to fully make sense, you need to be familiar with the terms open and closed when it comes to circuits. Simply put, an open circuit means there is a break in the path so electricity is not flowing, and a closed circuit means that there are no breaks and electricity is flowing. In order for the relay to open and close the NC and NO circuits, it must be sent a signal. The relay has a VCC pin for power, a GND pin for ground, and it also includes 1 or more input pins based on the number of channels the relay has, which are labeled in followed by a number. When a signal is sent over the input pins, the relay opens and closes the NC and NO circuits for the corresponding channel based on the type of signal received, low or high. Typically, you'll send a high signal to the input pin from your microcontroller, for example, to trigger the relay and have it open the NC circuit and close the NO circuit. When a low signal is sent, the relay will return to its default state by opening the NO circuit and closing the NC circuit. This type of relay is called an active high relay, as it requires a high signal to activate or actuate the switch. There are also active low relays, however, which operate with opposite signals. Essentially, an active low relay requires a low signal to trigger the armature, which opens the NC circuit and closes the NO circuit. When a high signal is sent, the relay returns to its default state by opening the NO circuit and closing the NC circuit. Of course, this can also happen when the power source is removed from the relay. I'm actually using an active low relay in this course, and because of this, there are a couple of things I'll need to do to get the code to function properly in the upcoming demos that you don't need to do when working with an active high relay. But as I mentioned before, I'll point those things out specifically when I get to them, so that if you're working with an active high relay, you can just ignore them and move on. Now the final term I want to give definition to that I've been throwing around in this lesson like it's going out of style is channel. When I say channel, what I'm referring to is a single switching mechanism on the relay board coupled with a group of terminals. The relay I'm using is a 2-channel relay, which means I have 2 sets of COM, NC, and NO terminals with which I can work. Each channel operates independently and has its own input pin to trigger its armature to switch between its NC and NO terminals. I won't be using both channels in this course, as the circuits I will be using can be constructed with just one channel, but I did want to make you aware that the multi-channel relays are available for cases when you might have more than one device that you would like to control. Alright, now that we have a better understanding as to what a relay does, let's see how we can actually control this beast using an Arduino and Johnny 5.